One to video 1.1a, but this time it's the advanced version. Still navigating the production file server, but now you're going to go from being in the junior varsity team to now the straight up starters in the varsity team. You have connected a laptop to the file server. That's all well and good. If I go to my computer, I can see that the S drive and the T drive are still there, which I can still browse them. So that was fine. But we really didn't know how any of this stuff really worked. It just, happened. We followed the steps and there we had the drives. But now we're going to take a deeper look into how in the world did that actually happen. Because it's really important as a help desk person or an IT person in general to be able to figure out why something worked and why something didn't work and know all the steps that happened in the background. So, for example, if we had tried to map that file server and it just completely errored out, we wouldn't have necessarily known at that level of just simply following those steps why it would error out. So at this point, we're going to figure out exactly how that happened. So I put together a PowerPoint here that will take us through the journey of a tale of a laptop and a file server becoming friends. And yes, I know that's incredibly nerdy, but hey, we're all nerds here, so it's all good. So here we go. So the first thing that happened is when we connected the laptop to the wireless SSID, which is really just the name that's broadcasted out there, the Transcend IT internal. At first, the laptop actually doesn't have an IP address. So the first thing a laptop or a desktop or an IP phone or anything that's going to talk on the network needs is an IP address. So the laptop literally asks for an IP address. That's the first thing anything does when it boots up. Is it's going to send out a shout out saying, "Yo, anyone got an IP address for me?" And that broadcast is sent in this weird message that's all Fs, which we don't need to get into all the nitty-gritty details about it, but basically it's just a broadcast. A broadcast is just saying, I don't have an IP address. If there's anyone out there that could give me one, I would really appreciate it. So at that point, it basically just sends the broadcast out through the wireless access point, obviously because it's wireless connected, and the wireless access point is connected to the switch. And so therefore, step number 2, the switch receives this broadcast, and it by itself doesn't really know what the heck to do with it either, but there's this thing called a helper address, which is configured in the configuration of this switch, which we don't need to get into exactly how it's configured. That's much further along. That's when we get into the networking portion of this curriculum, but for right now, just realize there is this thing called a helper address that is configured on this switch, and that is for the sole purpose of taking that broadcast and sending it off to something that can actually handle it, which is this thing called a DHCP server, which, by the way, this whole industry of IT is littered with acronyms, and DHCP is one of the acronyms, which you should have actually read at some point, either in some of the required reading or some of the other material you've covered in the Accenture curriculum. So DHCP stands for Dynamic Host Configuration Protocol, which literally just means dynamically giving hosts, which in the IT world, a laptop or a desktop or an IP phone or anything that needs an IP address is referred to as a host. So it's just basically saying dynamically giving hosts IP addresses is really what that is. So The helper address is set to forward that broadcast to a particular IP address, which is the IP address of the DHCP server. And at that point, the DHCP server says, oh, okay, I can actually do something about that. And the DHCP server gives the laptop an IP address of, now some of this stuff is going to sound a little arbitrary because we haven't really covered what IP addressing is or how in the world I came up with these numbers or any of that. But for right now, just go through this process just to understand the concept. We'll be going into more of these details in the networking section, but it's still important to understand how this all happened in the background. Just kind of take it at face value for now. And also, obviously, ask questions of your trainer if you really want to know some more details. So for now, we're going to say, okay, well, the DHCP server gave me an IP address of 10.196.4.x. And I'm saying x because this number will change. This last number, x, is just basically a variable or a placeholder that just says it's something between 1 and 254. Now, the reason it's between 1 and 254 is because of some things called subnetting, and it has to do with using hexadecimal conversions and all kinds of crazy stuff, which really doesn't matter. The theory of why an IP address is what it is isn't super important. It's just important to know that, okay, you know that these first three numbers are going to be what's referred to as a subnet, and then the last one is basically what's unique to each computer. So if I had two laptops, the first three numbers would be 10.196.4. Whatever, and then the last number would be what's unique. So for example, .10 for laptop 1, .11 for laptop 2. So the first three generally are going to be the same. So you can think of it as just literally grouping laptops together or devices together. So the DHCP server always gives up the first three the same, and then the last one will be what's unique. You can also think of it as, for example, this being the last name in your family. So for example, if your last name was Swanson, this would be Swanson, because you're saying, okay, everyone in our family has the last name Swanson, but the first name, which is this one, would be Bill or Ted or Jane, Samantha. So each person has to have a unique first name, and same with an IP address. Each IP address has to be unique with this last number. And by the way, that number is referred to as an octet. So just a little bit of theory. So you've got this IP address now, and you've got this thing called the subnet mask, which, again, we don't need to get into all kinds of details as to the binary or hexadecimal of how this is all put together. Just realize that these three numbers right here basically say it groups it together. So this 255.255.255.0 is just a way to essentially group every device into this subnet. So 10.196.4. whatever, this last octet or number being between 1 to 254 is based on the fact that this subnet mask is written out this way. It basically groups the subnet into a range of 254 usable IP addresses. So, in other words, I could have had 254 laptops connected to this wireless network, and they would have all gotten a unique IP address right here. On this last octet would have been unique. The first three would be the same, and the last one would be different. So the default gateway is what you would use to basically get out to the rest of the network. So this IP address would allow you to simply talk to other computers. So let's say if there was laptop 1 and laptop 2 over here, it would allow you to talk to each other because you would have the same subnet. You'd be on the same group, right here, 10.196.4. Let's say this one was .10, and let's say this other laptop was .11. You'd be able to talk to each other, but that doesn't really do you a whole lot of good to be able to talk to other laptops on your same network. What you really want to do is you want to talk to different servers and be able to connect to applications. You want to be able to go out here in the world of the internet and be able to browse to different websites and things like that. So in order to get to anywhere outside of this local subnet, you have to use your default gateway. So think of it as this IP address, and this subnet mask is basically grouping you together. So you're in your house, everyone's got a similar subnet right here, 10.196.4, so meaning everyone's got the same last name. Everyone's got a unique first name right here, which is this last number or last octet. But really, you're going to get sick and tired of hanging out in the house all day. You want to get out of the house. So in order to get out of the house, you have to use your default gateway. So this is your front door that says, in order to get out to the outside world, I need to basically hop onto this default gateway or get onto the default gateway first. So you route to this default gateway, and that's going to be your router that is at your site. And that's going to get you out to wherever. At that point, the router will take care of finding the next place you got to go. So that's really, really important. The IP address, the subnet mask, and the default gateway. Those are the most basic things you'll need to actually be able to route anywhere. Now, there's one other really, really important thing. The DNS server is something that will be able to resolve a name to an IP address. So meaning your computer, as the user, I should say, you type in a name, but really computers don't like names, they like IP addresses. But unfortunately, people have a hard time remembering random numbers like this, so there had to be something that converted the name to an IP address, and that's what the DNS server does. So your DHCP server is just giving you this information so that you can now do things on the network. So you have to have an IP address. Without an IP address, it's a lot like not having a name. You can't really talk to anyone without a name, right? And the subnet mask is basically grouping you together so that you're basically grouped into your family in your house, right? And then the default gateway is just saying, well, in order to get outside of this house, because you're sick and tired of hanging out with your own family members, you want to go venture out in the world, that is your default gateway. Now, the DNS server is literally saying, as a computer, you like to use IP addresses, which are these numbers that are pretty hard to remember. Users like to use names like google.com or, in our case, file mn550. Now, that was the name of our file server, but really computers don't really like using names. Names don't mean anything to them. The DNS server behind the scenes literally converted that file mn550 name to an actual IP address. So this is just literally saying to the computer, go talk to this DNS server and ask it what in the world that name actually means. Now, this DNS suffix, it's just basically saying inside of the Transcend network, use this domain name to basically resolve the names of computers. Not too important right now, it's just something that happens behind the scenes. The suffix we'll just kind of ignore for now. It's not super important. It's just something I want you to hear at least and get used to. Okay, so now the next step is the laptop, like I said, is going to ask the DNS server, hey, what in the world is file mn550 prod 01? I have no idea what that is because, again, these laptops or any device in reality has no idea what these names are. It needs the DNS server to convert that name, which is not known to it, into an IP address so that it can actually get there. The next step is the DNS server is going to say, all right, no problem. There's this thing called the DNS zone that is configured inside this DNS server. And there are these things called A records, which I'm just throwing these buzzwords out there so that you hear them often. It's not super important that we go into in-depth detail of what an A record is or what a DNS zone is. I just want you to know that they're there, and I want you to get used to hearing it. So it's not a big deal that you don't know what it is and that we haven't covered what it is yet. It's just to build familiarity. So not a big deal. So yeah, just ask the DNS server, okay, what is this, right? And the DNS server says, okay, well, I do have an A record for that. This file, mn550prod01, is actually the IP address 10.196.1.31. Now you may be wondering, which I wondered this when I first got into IT, like, well, why the heck don't we just use this IP address in the first place? Because it eliminates the need for DNS, and it seems more efficient. You may also not be wondering that at all, because a lot of people actually find IP addresses to be annoying. But to me, I always thought, well, if we can cut out the DNS server, why would you do that? But the simple answer to that is, people or users do not like to use IP addresses because it's not very user-friendly. And user-friendly is something you'll hear a lot in different documentation or just in IT in general. Is like you always want to set things up in a way that's easy for users to understand. So next step is the laptop now knows the IP address of the file server, which is 10.196.1.31, and it is able to connect to the file server. And as you recall, we were able to map the T drive, and life is good. So those are all the things that happened behind the scenes in an instant, pretty much. All those things, even though it was 6 separate steps, they all happened very quickly. I mean, we're talking in milliseconds, so a fraction of a second. These are all things that just quickly happen behind the scenes, but it's important to know that they happen so that if there's a problem, you can kind of break it down. And that's really it as far as the theory of what happened. So now let's actually inspect this ourselves. Instead of just taking that PowerPoint for granted, let's just actually validate this stuff, right? Let's put the proof in the pudding right here. So the way you can actually confirm this stuff is, I'm going to exit out of here real quick, is to go to your DOS prompt right here, this little command prompt, which we added to our taskbar. Just in case we haven't done it for some reason, you can go to the search, type CMD, right-click on here, and click Pin to Taskbar. So right now it's already pinned, so that's why it says Unpin. But if for some reason it wasn't already pinned, you can pin it right here. So I'm going to go ahead and click on that, which brings up this DOS prompt, which is a command line tool which you will use as an IT person. It's really powerful. You can do a lot of cool stuff with it. One of the most basic things you'll type is this command ipconfig. Literally, it tells you your IP configuration, so your IP address, essentially. So if you hit enter, there's a bunch of stuff that comes out. So if you look, this is when I typed it in, there's a bunch of information that comes out. So the thing to keep in mind here is you want to focus on the network that you're actually connected to. So this laptop has a wireless card in it. It has an Ethernet wired card, and it also has a Bluetooth network on it and all kinds of stuff. But right now, as you recall, we were connected through the wireless network. So all we really care about is the information about the wireless network. All these other networks are basically just disconnected. So we really just don't care about it. So as you can see, my IP address is 10.196.4.35, which we said it would be 10.196.4. something, right? Well, so these three again are the group or your family, right? So the first three numbers or octets that are separated by a period are what groups you together, right? So that's basically saying 10.196.4 is the common number, and then the last number is the unique number. So this is what each laptop on this wireless network is going to have, a separate number. So you could actually have one of your neighbors or one of your other trainee buddies go type this Ipconfig command, and they will have maybe 4.36 or 37 or some other number. But you will notice they have the same subnet mask. So this number is going to be the same for everyone on this particular network because, again, that groups you together. So that basically groups you in your house, essentially, part of the same family. And everyone will also have the same default gateway. So the default gateway, again, is what takes you outside of your house or outside of this local network. Think of it as the front door. You always have everyone, regardless of what IP address you have, in order to get outside of your house, everyone has to use the front door. So you may wonder, well, what happened to that other stuff? Like, where is that DHCP server, or where is the DNS server? Well, in order to see that stuff, you have to type an extra little thing. So you can actually hit the up arrow, which will automatically bring up the command again, which is a nice tip. Basically, instead of having to type ipconfig again, you can literally just hit the up arrow, boom, there it is. Now you do a space, and then you hit the / key, which, by the way, the / and the / are very different things, and they do completely different functions, so do not mix those two together. The / is generally on the same key as the question mark, so like that, and the / key is generally above the enter key. So that's a /, that's a /. Please do not get them mixed up. And it's also really important when you're typing command line stuff in the DOS prompt that you just go slow and steady. Don't just randomly type stuff and hit enter and see what happens. Just be careful because you can cause issues if you type the wrong command. So just always when you're doing command line, it's safer to be cautious and take your time, right? So ipconfig space / all. And literally this / is called a switch. Now, don't ask me why they call it a switch. It's just basically saying like it's an option that you have. It's like an additional capability that you use in that command. Instead of seeing the basic information, you do / all, and then that will give you all kinds of extra information. So you can see that that output was way more than the other output, right? So again, we are going to ignore these other adapters or interfaces, and we're going to focus on the Wi-Fi or wireless card because that's what we're actually using. So you can see here that I've got the IP address that we had before. I've got the subnet mask that I had before. I've got the default gateway that I had before, but now I'm seeing all this extra stuff. So I can see that my DHCP server is actually this. So that's pretty helpful for situations like when someone decides to be too clever and brings in their home router, which is a Linksys or a D-Link device, and plugs it in at their workplace, and it is a DHCP server. So it will give out IP addresses that weren't meant for your work network and will basically cause issues. So if you had a user that has accidentally connected to that Linksys or whatever, do an ipconfig, you will see that the DHCP server will be something that you didn't expect. So that's a really easy way to be like, hey, who in the world is giving out this IP address? Who is the DHCP server? And you can basically find out that IP address of the DHCP server. So that's very important. Now, we also talked about the DNS server, right? Remember, the DNS server is what allows you to be able to type something like file mn550 prod01, and the DNS server behind the scenes converted that to the actual IP address of the file server because, again, laptops and computers really want to talk with IP addresses. The names are just there for users. So DNS is there entirely for users to be able to easily remember names and have those names converted back to IP addresses. So that's how we can actually validate what's actually happening on the network. So if we wanted to, we could have actually, instead of connecting to this name right here, we could actually find out the IP address of this, and we could have actually mapped to that also. So I'm going to show you another useful command. So there's this command called Ns Lookup, and that stands for Name Server Lookup. Name Server is another name for DNS Server. So Domain Name Server is the server that would convert those names to an IP address, right? So when you type NS Lookup and enter, it connects to our DNS server. So inside of here, if you type file mn550 prod01, it should have actually converted that, but I'm going to troubleshoot this a little bit. It is probably missing this. So if you highlight this, you can hit enter, and then you can paste it after the prod01. Okay, so that's exactly what the problem was. I didn't use the fully qualified domain name, which was my mistake. But you know what? It's actually fine to make mistakes in troubleshooting. You can recover, right? It's not a big deal. So if you ever go into NSLookup and you type the wrong thing, it's going to just say unknown, can't find that. And that's because behind the scenes, when you connect to file mn550 prod01, it's actually using that. Remember I talked about that DNS suffix? It's using that whole thing, right? So this is like the full name of that server. And that's referred to as a fully qualified domain name. It's the whole name of the server plus the name of the domain. So by using this NS lookup, we were able to see that the server's IP address is actually this, 10.196.1.31. And again, when you're in this DOS prompt, if you just use your cursor and you left click and highlight something, such as this or this, if you just hit enter, it will automatically copy it. So I can now, it's copied, so now it's in my buffer. So a buffer is just basically in your operating system. It's a place where it stores stuff that you copied. So over here now, instead of doing / file mn blah blah blah, I can literally hit Control V, paste that, and this is the IP address of the server. So I'm still using that UNC path where you basically say / and then the name or the IP address. In this case, we're using the IP address. If I hit OK, now it's trying to connect to that IP address. And the reason it's prompting me for login is because I was connected to the name before, and now I'm connecting to the IP address. So it's wanting me to re-authenticate myself. So I'm going to have to put in the domain / my username, which again, the domain is transcendit, / my username is ted.trainee, but remember your username is going to be your first name / last name. And then I'm going to use my password. And I'm not going to click remember my credentials because I'm just doing this temporarily. I'm not going to be using this connection, so I'm just going to hit OK. So you can see that I was able to get to those same exact shares as I had before. It's just I did it by the IP address. So even if, let's say, my DNS server was offline or wasn't working, I would still be able to connect to the IP address because that's going straight to it. It's not using the DNS server at all. Think of it this way. If you were at your house and there was someone there that didn't speak your language and you needed a translator, right? So you had to go talk to someone else who then translated and allowed you to speak to that other person. Well, now you're just talking directly to the other person because you quickly read a book on whatever language that other person speaks and you were able to talk to them directly. So going to the IP address is basically bypassing that converter or that DNS server. It's just going straight to the device that you want to talk to. So it's really efficient and it's in ways easier, but it's all depending on if you think that remembering IP addresses is easy, which, most people would say it's not. So most people would say it's much easier to remember names. But from here, I could literally map a network drive just like I did before. So I just wanted to show you that. So at this point, you understand, and by the way, to get out of NSLookup, you just type exit. So to go back to our Ipconfig, at this point you understand that a computer has an IP address, it has a subnet mask, it has a default gateway, which again is the thing that gets you outside of your local network. It has a DHCP server, which is the thing that gave you the IP address in the first place, and also a DNS server, which is what converts the name to an IP address. Now in this case, we actually have two DNS servers, and that's for redundancy, which we'll be covering later. In well-architected or well-designed networks, you always have redundancy. So this is an example of where if this DNS server was to be turned off or offline, somehow this one would kick in, and the user, in theory, would not know the difference. So nice work. You have now gone behind the scenes as to what was actually happening in this environment where at first you just thought like, oh, this is easy. I just connect a laptop to the file server, map a drive. But behind the scenes, this DHCP server was involved and also this DNS server in order for you to be able to connect to the name of that file server and actually get access to those files. So when it comes to troubleshooting, it's really important to think through those steps that are happening behind the scenes and simply use some of these tools like ipconfig/all. So when people talk about tools in this industry, it sounds more than what it really is. Like, what do they talk about? A hammer and some nails and a, hacksaw, or what are they talking about? But literally, people will talk about like using the ipconfig tool, which really you're just going to a command prompt and typing a command and hitting enter and looking at it. Even though really that's not a big deal, people will talk about it as using a tool. So just keep that in mind. These are all little things that you need to have in your bag of tricks or tools in order to be able to troubleshoot something. So nice work. You learned quite a bit here. I would say at this point you probably understand more about how IP addressing and networking works than 99% of the population. So nice work. In a short period of time, you've learned a lot. Again, I do throw a lot at you in a short period of time. So if you have any questions, make sure you write them down and ask your trainer. Nice work, and we'll see you on the next video.